Hello, everyone, and it's such a pleasure to have here with us Professor Martin Chalfie, the 2008 Nobel Laureate in Chemistry. And he and his colleagues discovered something super important in science that I use every day and many other scientists use every day, green fluorescent protein. Marty, thank you so much for joining us in this episode of Rising Stars.
Thank you, Alan. It's a pleasure to be here.
Thank you so much. And Marty, I just want to start off with the very early part of your career. What I'm interested in is the part before you actually graduated from Harvard. I hear you weren't set on science back then. Is that correct?
I was set on science. So I was always interested in science and math.
Mm-hmm.
These were subjects I liked in elementary school, high school, college. I just wasn't very good at them. And but even more importantly than courses, I had a disastrous summer laboratory experience, and it was all, I believe, of my own making. I realized that if I wanted to go on in science, I needed to have some laboratory experience, and I arranged to work in the summer in a lab. Now, I did this sort of late in the year, and as a result, I was given a bench in an unused student laboratory. I was all alone, and I was about 50 meters away from the main lab with all the people in it that I should have been talking to. But the worst part of it was that I decided, for who knows what reason, that real scientists were able to figure things out completely on their own and never asked for help or knew what, everything had to come from them. And as a result, everything I did failed. And it was really a horrible thing. And I took the wrong conclusions from the work. I decided that this was proof positive that I should never be a scientist, that I was a failure and I should just quit, which is exactly what I did. I finished my coursework in my senior year and decided, well, that's the end of any career in science. What I should have concluded, of course, was, you have to ask people and you have to do the background reading and you have to do a lot more thinking and work in terms of the project than just thinking you're going to come up with something and follow some cookbook recipe and become more involved in it. So I think I took all the wrong conclusions from the work, but the net result was that I absolutely dropped out of science.
Wow, yeah, that's quite a story, especially looking in hindsight. And just briefly, what got you back into science?
So I did a whole series of very short-term jobs after I graduated from college. I wasn't really sure what I was going to do. And then I had a chance to be a high school teacher. So I was teaching in a private high school that was about 10 miles or so from Yale University. And as the first year of teaching was coming to an end, I made a discovery. And the discovery was that high school students have the summer off. They have vacation, but high school teachers have to find a job for the summer to keep themselves going. And I had a friend who had finished her Ph.D. or her postdoc working for a man at the Yale Medical School. And she suggested that I go and talk with him. And I did. I went and I had a nice talk with the man. And he described the project, which to me was fascinating because to me it's an example of a project that everyone should be thinking about, but nobody does. And that was, why is the eye transparent? How can we see through this tissue? How did that tissue become transparent? And he was, in other words, why is the cornea clear? And that was a fascinating problem. And he described a procedure that they were using to measure the transport of ions across the membrane. And to do that, you take the tissue, no matter what the tissue is you're looking at, and you put it in a chamber between two reservoirs, and you have electrodes in each one of those, and you measure the current that goes across the membrane. And so that's what they were doing. They were looking at this membrane. And to do that, the apparatus was invented by a Swedish scientist, Using, and so it's called an Using chamber. And when he mentioned that name, I got very excited because I had remembered writing a paper for a class 3 years before, and they had used the same apparatus, but I got things a little confused. Guy I was talking to, Jose Zadarnysky, he was looking at frogs and their corneas and looking at chloride transport. And the paper that I had read several years before and written about looked not at frogs, but at toads, not at cornea, but at skin and bladder, and not chloride, but sodium. So everything that I remembered about it was wrong, other than the fact that it used the same apparatus. And I remember the conclusion of the paper. And the conclusion of the paper was that the second messenger, cyclic AMP, rapidly increased the transport of the ions. And so I asked him in the interview, why does cyclic AMP work here? And he was very surprised because he said, you know, you're the second person in 2 days to ask me that question. I don't know. And I think because I asked him a question, he offered me a job for the summer. Now, I have to just back up for a second and say how stupid the question was, or how lucky the question was, because all these things are wrong. This is the equivalent of saying, oh, you ran a gel. I remember reading a paper running a gel. Do you have the same results that this other paper had? There's no connection at all with this. But he hired me nonetheless. I consider that the first miracle. And then about a week later, we're talking about 1970, or 71 rather. And 1 week after I start, he comes in and says to everybody, goodbye, I'm going to Europe to do my own research. See you at the end of the summer. And he leaves. So I'm there technically still on my own, but this time I've got the good sense to go and talk to people. How do I set up the apparatus? How do I get it to work? And I find that other person who asked the same question because I'm interested in that question because I thought of it. And I go and I talk to him and I say, well, how would you test this? And he says, well, the first thing I would do is I'd set up the apparatus and throw adrenaline on this. See if that increases the cyclic AMP and see if it works. So I spent the summer not doing the experiment that I was assigned to do, but doing this experiment. And I put the adrenaline on and the current went off the chart. It was a spectacular success. And I did other experiments to confirm it. I did other things, other experiments, talking with this other person. We figured out other things to look at. And at the end of the summer, the head of the lab comes there and asks me what was the result of the experiments he had assigned me. And I said, I don't know. I didn't do them, which I think surprised him a lot. And I said, on the other hand, here is what I have, and I've gone to the library, and here's the research I've done on this topic. And he was very happy with the result. That actually wound up being my first scientific paper. Was that work. So a little bit of nerviness, I guess you would call it, a little bit of independence, but also really relying on other people and talking things over, being able to do the one thing I think I could do, which was go to the library and look up things and see whether there was related information. And there's nothing like a little success to make you feel, well, maybe I should do this some more. And that motivated me enough. And frankly, Jose's support motivated me to apply to graduate school and then go there.
It's an amazing story. I mean, a story about curiosity, asking questions, not giving up, even though failure, as you mentioned, is completely normal part of science. I would argue that many more experiments fail than they actually do, in the end, succeed. But what kept you going on? And so many great pieces of advice really there. What kept you going on? What inspired you later on during your career to pursue or continue science? Was it the joy of discovery? Was it something else?
So I've always enjoyed coming up with the ideas, many of which are completely wrong. I like the idea of making connections between things. I like thinking about them. Insight doesn't come all that frequently, but when it does, it's exciting. And to feel that you're making connections, I think, to me, that's more exciting than the actual doing of the experiments. Frankly, it's the interacting with people, interacting with the literature, going to a seminar. We have a journal club in the lab, and I think everyone in the lab is a little bit annoyed with me because I always ask the same question of every paper. What in this paper could we apply to our research? And sometimes it's very remote, sometimes it's very specific, but it's always, does this remind you of anything? Does this connect to anything? And that's something that I do enjoy. It's the sort of puzzle aspect of all of this. Not that it succeeds all the time or even most of the time, but I like getting excited about the ideas.
Yeah, I mean, that's definitely a great part of science. And the last couple of questions, Marty, this really short but great little chat between us. What do you think are the most important barriers that stand in the way of scientific progress, especially maybe for younger people? Is it the giving up part? Is it something else? What would you say?
I think that well, I can't speak for education all over the world, but I can speak for it here. We put a very high emphasis on achievement. And I think, as we educate people, sort of build up hierarchies, build up, this is the right thing, this is the wrong thing, you have to succeed. I think that we treat things as if they're a zero-sum game, that there are going to be winners and losers, and that we can't make a mistake. One of the things, I don't know if it's said other places, but certainly I've heard it a lot here in the United States, is we say to very talented students who we wish the world for, we say a horrible, horrible thing to them. We say, follow your passion. And I know if anyone ever said that to me when I was starting off, And I've seen it in the eyes of people that hear it now among students. It scares the hell out of them because they say to themselves, look, I don't actually know what my passion is, and I don't want to make a mistake. I don't, tell me what I should be passionate about, or what my passion should be, and I'll do that. They want sort of that sure road ahead. And we sort of have convinced people that that's the right way of doing things. I don't think so. Maybe because my road has been very non-linear. It goes in a lot of directions. I think that the important thing, what we should be saying, is not follow your passion, but be passionate, be involved, be committed to what you're doing. And it really isn't going to make that much of a difference as long as you get completely involved. Not that you're going to solve any particular problem, but the accumulation of experiences is going to help address new situations, new environments, new problems that are going to come up. So I think the idea is just be passionate about it, be involved. Don't judge yourself. I think there's much too much judging of our own abilities. And, what I've just said is really, I have a feeling about advice. I think everyone gives advice, actually not to anybody else, but they give the advice to their younger self. So I was really talking to myself. Don't accept these judgments of other things. How other people deal with things, you can just wish them the best and hope that they succeed. But I'm not really sure how one can succeed. This is in line with my proof that the vast majority of Nobel Prize winners have no idea how to get a Nobel Prize.
Yeah.
And the proof is that the party is so much fun that I cannot imagine anyone going through it that would not enjoy it again and again. And so few people ever get a second prize because we don't know how to get them any more than anyone else. You do the best you can. There's a famous Broadway musical, Guys and Dolls, based on a series of short stories by the writer Damon Runyon. And it's all about the petty crooks in New York in the 20s or so, and the 1920s. And in the book, there's always somebody that comes from out of town and that is naive and is talking to one of these petty criminals. And in all meaning says, what do you do? And the person he's talking to doesn't want to say, actually, I run a crap game, or I'm a petty crook, or this. They always have the same answer to what do you do? And the answer is the best I can. And I think that's pretty good advice.
Yeah, I think that's a great piece of advice. And Marty, just to finish off with one very brief question about open access science and just open science in general. What are your thoughts on it? Do you support it or maybe don't support it? I'm asking this primarily also coming from a university where we didn't have lots of journals that were open to us, and then you have to kind of go around and somehow download the articles. So just a few thoughts about that.
So the first thought is that I think one of the most positive things that's happened in biology is to take on what the physicists have done and use preprint servers, particularly bioRxiv is the one that's usually used. And so many people over the last, I'd say, 10 years have accepted and promoted the idea that when you have a paper that you want the world to see, that you put it, not only do you submit it to a journal, but you also put it on a freely available preprint server like bioRxiv. Physicists use arXiv. And so everyone in the world can see it without special subscriptions or anything. It is freely available to everyone. And it's also the most recent work. So I strongly advocate that everyone do that. And I'm really encouraged that many, in fact, I think most people now do put their papers in a form that makes them freely available. I think that's very important. However, I do want to make one caveat. And I sort of slipped it in earlier, and that was the idea. When you want the world to see it. So I don't think people, if you think you've made a product or you've made something that you think should be patented, and that's not a judgment I'm going to make on other people, but if you think that, the patent rules are such that you cannot tell people until you've applied for the patent. After you've applied, so don't put it on bioRxiv until you've done that. So it's not it's not the minute you have your data, put it there, or when you have half of paper, put it on bioRxiv. No, when you want the world to see what you've accomplished, you should let the world see what you've accomplished. I think I think it's very important, because the review process for papers is often very, very long. And by the time the paper finally gets published, it might be a year or more since the work was finished. And while there's always improvements from peer review, it still takes a great deal of time. And I think the information should be available to people. I think we saw this during the COVID-19 pandemic, when a lot of the information about treatments and studies relating to the pandemic were made available as preprints, and people recognized they were not peer-reviewed. They had to use their own judgments in terms of how they were thinking about the material, but the ideas were out there and people were able to talk about them. They weren't hidden behind some publishing wall to prevent people from thinking about these things. So I think we have a good precedent for this.
Yeah. Marty, it's such a pleasure always talking with you, especially today. And I'm really in a lucky position to talk to great people such as yourself through these interviews. So thank you very much for being part of Rising Stars.
Thanks, Alan. Take care.